Hello and welcome to Computer Tech and More. Today we're going to be taking a look at two Corsair fans, the AF120 Elite and the SP120. So this is part of my retesting analysis where I redid all of my noise testing analysis. First up, we're going to do a little bit of explanation, and then we're going to get into the new versus the old data, and then the detailed graphs and explanation. Let's get right into it. So first, what is my previous analysis? Well, my previous analysis is not completely invalid. It just ended up not testing exactly what I want to test. So I placed my microphone really close to the edge of the fan because I'm in a fairly noisy environment in my home office, which averages around 32 decibels in noise volume. So to compensate for this, I placed the microphone close to the fan tip. Unfortunately, that caused a lot of fan interaction with the blades. Very similar to if the fan was up against a mesh filter or in a pull configuration to a radiator or heatsink. So that's what I ended up testing, how this fan does in a pull configuration up against a mesh filter or up against a heatsink. Not exactly what I wanted to test, but still valid nonetheless. Also, I wasn't paying a special close attention to the room environment, how noisy it was. Mind, it was always within a very similar level, but it was in the end about plus or minus 4 decibel range. So that is an 8 decibel range total. So every 10 decibels is a doubling in noise volume. Going forward, I now have a pole that I may use as a measuring stick. That is a fixed distance from the fan blade to the microphone itself. I also make sure that the room environment is always within the same level, a plus or minus 2 decibel range. So that gives me 4 decibels as a total range. So overall improving the accuracy. Unfortunately, this is where my testing dead ends. It's where I can no longer make improvements without help from essentially income into my channel. So viewers like you, a sponsorship, YouTube paying me, something like that. Because I want to make a little test chamber to absorb noise level. I want to get a better dedicated microphone for noise testing. Build a little test system. I want a better, more accurate anemometer, something that is accurate within plus or minus 0.01 meter per second, while the current one is accurate within plus or minus 0.1 meter per second for finer granularity. So all of this adds up, and to get myself to the next level of testing, I figure it's about $2,000. I know that's a lot to ask, and I don't ask it from just one person, but if those of you who are able to support, you like what I'm doing with this channel, I ask that if you can help out, join me on Patreon. As soon as I meet that threshold, I'll be upgrading my whole testing methodology, and we'll retest every single fan I've tested thus far with that new testing methodology. Until then, I'm going to keep going as I'm going, exactly what I'm doing. No ifs, ands, or buts, because this is a fundamental interest of mine. I just want to get that clear, and I'm not just here sitting on my high horse being like, you need to give me money, because that is not the point. I'm going to keep going with what I can do. I just want to let you all know what the goals for this channel are. So that leads us to the original testing methodology to the new testing methodology. You got the fan rank, the model number, the RPM, and the test being performed. And one additional thing, at 100% PWM fan signaling, we got one additional column for noise level it generated at that level. So let's get right into it. One additional note with the testing methodology, if you're new to this channel, I do ask that you watch the second part of this video where you go over the detailed explanation of what each graph is, why it's important, the detail that was analyzed, and all that final granular stuff. If you're returning to this channel and just want to see what has changed from the new to the old testing, or old to the new testing methodology, you can just get this brief overview in the first section of this video. All right, now let's get into it. First up is the CPU air cooler testing, noise normalized. The AF120 Elite was originally ranked 9th. It is now ranked 36th. The IQ SP120 was originally 30th. It is now ranked 42nd. Overall, a loss in position for both these two fans. At 100% PWM fan ceiling, the AF Elite was originally 22nd and retains that position. The IQ was originally 41 and retains that position. Value processing, cooler test, noise normalized. The AF Elite was originally ranked 18th. It is now ranked 35th. The IQ was ranked 35th. It is now ranked 40th. So a loss in position for both of these two fans. Cooler testing, value proposition, 100% PWM fan ceiling. The AF120 Elite was originally, it retains its position at 35. The IQ retains its position at 40th. CFM testing, noise normalized. The Elite was ranked 8th. It is now ranked 33rd. The IQ was ranked 25th. It is now ranked 34th. Noise normalized, or 100% PWM fan ceiling, CFM test. The Elite was ranked 28th and retains that position. The IQ retains the position at 37th. CFM testing, value proposition, noise normalized. The Elite was ranked 14th. It is now ranked 34. The IQ was ranked 33rd and is now ranked 32nd. At 100% PWM fan signaling, value proposition, CFM test, the Elite retains its position at 32nd. The IQ retains its position at 36th. Case simulation test, 6-inch mark, noise normalized. The Elite was ranked 8th. It is now ranked 32nd. The IQ was ranked 42nd. It is now ranked 46th. So both a loss in position. Case simulation test, 11-inch mark, noise normalized. The Elite was ranked 11th. It is now ranked 32nd. The IQ was ranked 47th. It is now ranked 46th. 6-inch mark, value proposition, noise normalized. The Elite was ranked 18th. It is now ranked 34th. The IQ was ranked 44th. It is now ranked 47th. 11-inch mark, noise normalized, value proposition. The Elite was ranked 17th. It is now ranked 33rd. The IQ was ranked 47th. And is now ranked 47th. So like with other fans, I try to test for consistency's sake, running through several passes, and it's hard for me to determine if there's quality control issues within a fan itself. For future testing, I would like to acquire multiple samples of each fan so that I can determine if there are quality control issues within a manufacturing process, as well as longevity testing. It is something that I'm currently not able to do, how long these fans are going to function for. Now we're on to the detailed graphs and descriptions. First up is the case simulation test. This can be looked at a couple of key different ways, but first and foremost, the most important for you, the viewer, is what size computer case do you actually plan on buying. So I took key measurement points that are the distance from the front of the case to the rough position of your CPU socket. So we took the 6, the 9, the 11, and the 14.5 inch marks. The 6-inch mark is representative of your small form factor cases that are a front-to-back airflow design, not the ultra-compact ones like the Fractal Design Terra, which sucks in air from the sides and sucks it out and then blows it out the top. Not like those ultra-compact ones. So a front-to-back airflow design. This sort of data is most important for air-cooled type systems, and I'm going to get into that in a minute or so. The 6-inch mark is also representative of a short throw distance, meaning if you have fans in the bottom of your case and you're blowing them up towards your GPU, that would be an example of that short throw distance. The 9-inch mark is representative of a compact tower. Again, front-to-back airflow design, probably holding an ATX or MATX sized motherboard, and the GPU would be of that length overall. So again, a front-to-back airflow design. The 11-inch mark is representative of your mid-tower cases, something like the Meshify 2C, Corsair 550D, Corsair 500 series, this Corsair Stormtrooper looking case. Basically just whatever you think of as a bog standard mid-tower case. The 14.5-inch mark is representative of your large towers. So longer, taller, bigger, like the Fractal Design Torrent, fit into that size category. And again, this is from the front of the case to your CPU socket. So for optimizing how well the air travels through your case and for best overall thermals, you want to have a good strong airflow going into your CPU fan. Because the way the fan works is it sucks in air, so it actually pulls a minor vacuum in front of the fan to then accelerate the air through it. So you actually want to fill this vacuum with air as quickly as possible. So having a good quality fan in front, supplying this fan with air, will improve the overall efficiency and drop the thermals of your actual CPU. I plan on doing testing of this in the future to show what kind of improvement you actually see with poor airflow versus high airflow into the CPU socket. So I hope you're looking forward to that. As for if you've got a radiator, the radiator, or actually heatsinks, naturally straighten out the airflow. It's like a flow straightener. So that the airflow coming out the other side of that is in a more streamlined fashion. So the reason I bring this up is if you have an water-cooled CPU but an air-cooled GPU, you still want a good steady stream of air leading into the case so that the GPU has plenty of air going through it, even if that air has been warmed by the CPU. And you may want to run your CPU fans in that type of scenario at a little bit higher speed so that the air traveling through it will be a little bit cooler. You'll have to sacrifice a little bit of noise performance to achieve that. So that's where you try to pick the best fan with the lowest noise level for the maximum amount of airflow comes in. So my opinion is you don't want to get any of these old style static pressure fans that tend to spew air off to the sides because they're less versatile. They only work in one type of thing, and that is in radiators. While concentrated airflow fans are going to be good in everything if you get a high quality one. So that's where my data comes in from the case simulation test, because it can also be used for what kind of flow pattern does this fan generate. If the fan drops off steeply like the SP120, then it's not very effective in that case airflow design and has a tendency to spew air off to the sides in every single direction. Not a good result. But if it has a very constant airflow, meaning it loses very little airspeed from the front of the case to the back of the case, then it is very well optimized and would be highly recommended for its set of use. So how does it compare against, well, my control fan? The control fan is here as a baseline measurement. Not to compare against other fans, but just to compare against something that is steady state between all of my reviews. So the control fan is 3 parts A12X25 to 1 part A14. 140 millimeter fans like the A14 tend to do better at the 11 and 14.5 inch mark, while smaller 120s tend to do better at the 6 and 9 inch mark. Where the 9 and the 11 inch mark kind of crisscross between different 120s and 140 millimeter fans depending on their optimization. But what I said is the general tendency to be true. So what do we see from the Elite and the IQ? They're both fairly poor performance. I'm sorry, I've got a little bit of a cold, so my voice is a little bit unsteady, but I'm going to do the best that I can do. So they're 10 towards the bottom of the graph, so I put them in the poor performing type category. At 100% PW fan signaling, well, the IQ is dog crap. Just plain and simple. If you're using it in a smaller case, it'd actually be okay, but no. The Elite, on the other hand, is still underperforming. I would put it as an okay type category. Now, how does it compare against other fans? First, one note. This green line here is the Wonder Snail. I have this fan marked as the bottom end of what I consider a good fan, and simply because of how it ranks at the 14.5 inch mark, where it does really well compared to most of their fans. It just has a particularly efficient blade design with creating a good concentrated airflow, even though its 6 inch mark is not very good overall compared to the other fans that I have in the good category. So really, we're looking for north above the Wonder Snail. So the Elite is underperforming compared to the Wonder Snail, and the IQ is not even worth considering in this type of case. I mean, IQ is a pressure-oriented fan, so it makes a lot of sense, but the AF120 Elite is supposed to be an airflow fan, and it is completely underperforming. Now, we do have the 100% mark, but if you're running your case fans at 100% PW fan signaling, something's gone terribly wrong inside your case, and you may need to rethink about how your CPU socket is, or your cooler is mounted to your CPU socket, because if your fans are linked to your CPU, there's some no, overheating. If you're using a radiator, then that's different. So the Elite is still under the good fan category, and the IQ is bad. Okay, now we're on to noise versus airspeed. I use for this graph, I use the 9 inch mark, and the reason for that is that most fans that tend to drop off between the 6 to the 9 inch mark, and I needed airspeeds over 0.5 meters per second in order to get good reliable readings. You will note that the IQ is under 0.5 meters per second, so its reading is very unreliable here. So we're going to do the best we can. And the data points could have been taken at the 11, 14.5 inch mark. I just chose the 9 inch mark because I needed higher airspeeds. Now, all of that said, here is the IQ. You'll notice this lunge out. This is where I hit a harmonic frequency within the fan, where it gets all of a sudden a lot noisier without gaining really any extra performance. And then it comes back to normal. And then apparently I hit another harmonic within the fan. So that is just a general note with this sort of design. The Elite, on the other hand, is much more streamlined. I didn't hit any harmonics within it, but its performance was still not that great overall. It was still underperforming compared to other fans, and the fans listed here would be all considered a relatively good type category fan. Next, we have through airspeed through my CPU air cooler, the Noctua U12A. On both these graphs, better fans are going to be sitting in the top left, worse fans are going to be sitting in the bottom right. And let's focus on the left side first. This is RPM versus airspeed. Airspeed is vertical, RPM is horizontal, and this is effectively a blade efficiency graph. It is how good is this blade design at shoving air through my CPU cooler. And we see that both of these two blade designs are slightly better than my control fan. Again, that control fan is a blend of two fans, the A14 and the A12X25. So that is a good result for at least the blade design. In terms of noise versus airspeed, this is where things kind of fall apart for these two fans. The Elite starts off pretty good and then it falls dramatically behind, while the IQ starts off pretty far behind and then sort of catches up at the end. But I wouldn't call either of them good. They're just too noisy across the majority of their RPM and airspeed range to be really worth considering, in my opinion. Next, we have how they compare against the other fans. First, a little bit of explanation over here. So I did a whole series of tests on my CPU air cooler, letting it go to thermal max, measuring the airspeed through it at different PWM fan signals, letting the wattage stabilize, and then being able to generate a graph for what airspeed equated to what wattage going through the CPU. So this is for my CPU, the i7-11700K, and for my particular cooler, the Noctua U12A. So if you don't have either of those, how can you use this data? Well, you can use it as a comparison standpoint because the airspeeds will vary based on the thickness and fin density of your particular cooler. But let's say you're starting off with the SP120. In my cooler, it's got an airspeed of this, but in yours, it would be something else, but it would be in relative disposition. So if you upgrade to something like the A12X25, you're now going to be pushing a much higher airspeed for that same noise level. So what does this mean? It means that if you've got an unlocked CPU, you're going to be able to draw a higher wattage for the same noise level, or if you've got a locked CPU or limited clock speed, you're going to be running your system cooler at that same noise level, or you can take this extra overhead, back off the PWM fan signal a little bit, and now your system's going to run quieter for the same original wattage, or ability to draw wattage. So that is how I would use this data. So with regard to that, the Elite and the SP120 are towards the bottom end of the graph, not an overall great position for them to be in. At 100% PWM fan signaling, the IQ is not in a great position, right in line with the TLG12, which is one of my top value picks. With regard to its RPM range, it's actually pushing the right amount of air, but I guess I find it underwhelming. The Elite, on the other hand, is sitting right where you would expect it to be based on its RPM. So sitting right in the middle of the graph, right in line with the A12X25. But let's look at the noise level. It is almost, not quite, 10 decibels, like 8 decibels louder. So that is quite a lot noisier for the same effective airspeed. So not a great result from the Corsair fan overall. Now let's look at airspeed through the cooler versus noise. And we see that the IQ climbs very steeply, but it still stays under the good fan category. And it does become better at higher RPMs, higher airspeeds than the Elite. The Elite, on the other hand, creates a much smoother curve, more like the other fans, but it stays well below the performance of the other fans, indicating that it's just not that great at this particular job. So let's move on. Now we're on to CFM testing. CFM testing, as most other reviewers do it, I don't particularly like. I think that they don't understand how like the science of fans actually works. So allow me to explain. First, what is CFM? CFM is a volumetric flow rate, cubic feet per minute, and you can have it in any unit you want. I believe that Noctua uses meters cubed per second. It's just a unit conversion and it's easy to do. But the basics of the test. So you have a fan. It's not imaged correctly in this picture, but the fan is the same size as the tube. You have a tube minus circular, so how do you measure the surface area of the tube? Well, it's pi r squared. So let's put r as in feet. And we need to have an anemometer. We measure the airspeed. It's in feet per minute. So feet per minute times feet squared is cubic feet per minute, or feet cubed per minute. And that's how you get the volumetric flow rate. Now, the reason I don't think this test is valid for a case airflow test is because you have the fan, it's the same size as the tube, so if the fan has a tendency to shoot air off to the sides and it's blowing in the tube, the air has nowhere to expand, so the air is just going to all travel down the tube. Mind the fan's momentum, blowing air off to the sides, it's going to hit the walls of the fan and create a larger boundary layer or section of slower moving air closer to the walls than one that has a nice concentrated airflow. So there's going to be a tendency for one that shoots air off to the side to have lower performance than one that has a concentrated airflow, assuming everything else is the same. So you're going to end up with the right result, but for the wrong reason, and they're going to look much closer together than they actually are. Meaning that the two fans, one that's shooting air off to the sides and one that's concentrated, are going to look very close in performance, when in actuality they're not. Which is why the case simulation test is actually so important. That's not to say that a CFM test like this isn't valid. It just needs to be used the right way. As a scientific test for how effective a fan is in for generating PQ curves, so pressure versus airspeed, it's perfectly valid. Noctua uses it all the time in other manufacturers, and it's perfectly valid for that type of circumstance. You'd have a slit, it can be varied in size, you'd have a couple pressure sensors, you need to measure the airspeed, and you'd be able to generate the curves for how effective the fan is in different types of pressure scenarios, including no pressure. But it doesn't tell you how good the fan is inside a computer case, meaning how good the airflow is. There's only one channel out there, actually it's not even a channel, it's a website called hwcooling.net that uses a cone-shaped CFM test that I actually particularly like and would like to implement in future testing. So I would need one 3D printed. Again, this is all future things that I'd like to add to my testing, assuming I ever get there. So I just wanted to give that brief little explanation. Any reviewer who's just doing a CFM test like this and saying this fan good for case airflow because high number doesn't understand the science and probably shouldn't be trusted for at least case airflow design. Doing heatsink testing is very simple. We saw that you just need to measure thermals, or you can measure airspeed going through it and equate it to a wattage. Either way, in my opinion, is perfectly valid. I am an aerospace engineer. I have a background in computational fluid dynamics in my master's degree, so I think I'd like to be considered a trusted source on this topic. So kind of a case in point, we see in the CFM testing, the IQ is slightly outperforming the control fan and the Elite, despite it being slightly worse in other tests. So this kind of is proving my point that this test is fundamentally not what you want to use for case airflow. Now you can use it for like CPU cooler testing and other stuff like that. And we do see a lot of variation once you add noise into the factor, because then we're taking into account how noisy the fan is, and we do see a similar result to what we saw before, where the IQ climbs steeply and the Elite kind of drops away more steadily. So how do they compare against other fans? Well, they're definitely towards the bottom of the stack. Not much more to say. I'm going to just leave it up for a couple more seconds. How about at 100%? Well, towards the bottom of the stack. Actually, here the Elite is well off the beaten track of the A12X25. How about noise versus the performance? Kind of similar to what we saw before. The IQ climbs a bit more steeply, but is still towards the bottom end of the stack of good fan category, while the Elite starts off kind of okay and then kind of falls way behind considering its overall RPM and everything else about it. Now we're on to value proposition. The AF Elite is a $25 fan, the IQ is a $24 fan, and some change. So value proposition is a very simple calculation, is performance per dollar. And it's most important for those of you who are trying to squeeze every penny out of your build to get the best bang for your buck if you got a little bit of extra money to spend. So that extra category would be better noise performance, better maximum performance, better choose your RGB, choose your whatever. So if it's performance data, you would use the earlier data and compare it with the value proposition to pick the best fan for your particular category. If it's an aesthetic, like RGB or a particular appearance, then you'd have to determine that extra with your own right. I can't make that decision for you. It is up for you to decide. And one other note, value proposition is not maximum performance. It is simply a performance per dollar. So you do need to make sure that you're hitting the performance mark that you actually want, and not just, hey, this is a good value, and then find yourself disappointed that you didn't achieve the thermal results that you wanted, only picking out the best value. And you've got an unlimited budget, buy whichever fan you want because you got the unlimited budget, so go for it. So at the 16th mark, noise normalized, we do see that the IQ and the Elite are underperforming. The Elite is almost at average in terms of its value proposition, but it's actually a little bit under. So at 100%, you shouldn't be running your case fans at 100%. But assuming you are, the Elite is sitting right about average. The IQ is sitting under average. The 11-inch mark. The IQ is non-existent and should be completely ignored for any cases larger than a compact tower. As for the Elite, it's sitting below average. I really wouldn't recommend it. Just gonna move on. Performance for the CPU cooler. Both of them are sitting under the average mark for value proposition. So again, not a great pick overall if you're looking for value. At 100%, they're still kind of below the average mark. The Elite is sort of closer to the average, but we're going to just move on. And then for CFM testing, they're both kind of below average once again. So where does that leave me with this fan? Well, the Elite originally performed a lot better in comparison, so either it does really well with the mesh filter directly over top of it, or I got a really bad sample for the second set of testing that I did because I acquired a new fan. So this will be added into the grouping of fans where I need to test it a second time. So the Elite, the P12 Max, the ARGB here, and some of the Cooler Master fans, I want to acquire another sample to see if I just got a lemon the second time through. And it's currently outside my purview to do like quality control testing with these manufacturers. It's, again, something I'd like to add, just like longevity testing. It is something I'd like to add that I'm currently not capable of doing. So if you would like to see this channel grow and improve and do more detailed testing, hit that subscribe button, join me on Patreon. It'll allow me to get there and acquire this next set of testing equipment to really be like, have everything for you guys. And last, but certainly not least, at the end of every video, I do like to show off my raw data. This data does belong to me. However, if you would like to use it for your own personal use, meaning you just copy it down and put it into your own Excel charts to check value proposition down the road, compare them, create your own charts, you're more than welcome to do so. I do ask, however, if you use it in any sort of publication, written, journal, video, whatever, anything like that, that you reference me in my channel because I'm the one who generated this data. It takes me about 1.5 to 2 hours to generate this level of data for my videos. And then additional time to just record, create the script, the graphs, update the graphs for each video, and that sort of thing. And then, of course, editing. So I appreciate that. If you've got suggestions on how I can improve my videos to make them better to watch, more enjoyable, whatever, anything like that, I'm looking for constructive criticism, not just ranting and raving. I'm more than welcome to try to implement it into the future. If you've got suggestions for fans for me to take a look at in the future, please leave those in the comment section down below. I do ask that they be available on Amazon because that's just the easiest way for me to acquire them currently. Other than that, please hit that subscribe button, hit the like button. It really helps my channel. Join me on Patreon. It will help me grow and being able to acquire that test equipment that I have been talking about all this video. And, well, I hope you have a great day. I'll see you next time on Computer Tech and More.